chapter 11, soil and water resources. Starts out with this picture of a rice terrace. Has anyone ever been to any of these terrace farming? I went to one that was in China, and it's actually a place that had a very similar name to the place in the book, Luzon. Well, as you kind of go down the mountainside, you can see the whole area is very, well, this lighting isn't the best. This specific little village actually had to change over their agriculture because these were classically used as rice terraces, but they had said that the air had become drier through time, and rice takes a lot of standing water, right? You have to have standing water, and they weren't just getting enough moisture, so they are switching to some different crops. But the features are the same. These are actually little things. If you were a tourist and you wanted them to carry you around on a little thing, like you could do that. I didn't pay for that. I didn't want them carrying me around. But as you can imagine, going and visiting mountains has lots of ups and downs, lots of walking. This is the crop that they had switched to out drying. They pick it and dry it out so that it's cheaper to pay for it to travel if it has lost its water content, right? It's lighter. Anyone want to guess what these are? Too far away? Anyone have any Chinese food that had anything red in it? No ideas? Oh, this is one of those things that I was saying that you could carry people around in, or be carried around in. And these farms did take generations of time to carve out of the mountains, and they go through a huge area of land, because China has had a very big population for a long time, still does today, and it needs as much food as possible, so they converted as much agricultural land as possible. I should turn off some of these lights. It really washes out the color. This is that crop that they are switching to that per unit it's more valuable than rice. Oh, thank you. Yeah, let's keep it like that. All right, now I'm gonna go back a couple slides, see how much better it looks. Looks a fair amount better with some different lighting. Okay. Oh, and when we left, there was a guy who had a pet duck in the bus, which I thought was kind of cute. All right. So on the topic of soils, well, this chapter points out that many, the chapter doesn't point out that many past civilizations have fallen because of environmental problems. They focus on the Maya. I don't know if people know a lot about the Mayan Empire and whatnot. Central American Empire, they had language and they had math and they had a calendar and they had lots of things, and lots of civilizations that thrived in different environments. If things change up a bit, your weather changes quite a bit. Actually, I was reading about past climates in the Sahara Desert, and the Sahara used to get some of the monsoon rains that now go to India. Well, things can change a lot through time. There's a number of civilizations there that also vanished because of sudden lack of water. The Maya fell about 400 years before Columbus came. And so if they hadn't fallen at the rate they were going, they would have probably been technological equals with the Europeans. But that civilization did not last. Again, mostly because, well, if you're in a tropical area, you have all of your nutrients are leached out of your soils because of all the rain, if you remember us talking about this before. Mayan ruins. All right, so what is soil? Soil isn't just dirt. I mean, it is dirt, But soil is actually the combination of all the different areas that we're studying in this book in this semester. As it needs to be aerated, right? It has air moving through it. Obviously water, biosphere, living organisms, bacteria and whatnot, lithosphere. Of course, that's the parent material, whatever rock that is there, right? All these things come together to form soils. Soil formation. Well, soils come about through weathering, right? I like visuals for things. So if you can imagine an island appears out of nowhere, right? Like maybe it had a glacier on it or something, melts. Well, the land itself, it's usually pretty rocky, right? It's mostly made up of bedrock, its parent materials, and it takes time for these soils to develop. You have to have your pioneer species that come in and they start kind of aerating the soil and also breaking down the parent material, the bedrock and everything. Then through time, if that builds up, you get animals, right? You get larger trees, you get more diverse forms of things going on. And this all kind of churns up the soil and makes it richer through time. Now you could have places, using the example of a glacier that receded, there's in the far north and far south, there's plenty of places where your soil is just very underdeveloped because there hasn't been any time for it to have all that stuff happening because it's mostly frozen through much of the year. Bedrock, did I make it clear before? That is what if you're building a skyscraper, you're going to want to build it on bedrock, right? Because that's the part that's going to be most structurally sound. Although you could build buildings on not bedrock, but you don't want to have your skyscraper on loose soil, right? Example, some of this, like I said, your bedrock is pretty solid, but then as it gets broken down through weathering, erosion, rain, also of course plants and animals tearing up the soil. Soil characteristics. Well, we identify soil by their color, because their color shows their chemical composition. And soils have different horizons that come through time. These are different layers of the soil. So just showing some of that process. If you just imagine large amounts of time, imagine some precipitation. The water goes through the soil. Often it will dissolve elements of the soil with it and take those elements with them, further mixing up the chemical composition of the soils. And then when it's not raining and you have a lot of sun, water is brought up from the water table, right? You have roots that will soak it up, but also just goes up through the rocks, through evaporation on the surface. Soil particles. Again, I think a visual is good for all this type of stuff. A number of these terms we've actually used before. In a nutshell, with weathering, right, you get soils that are developed because maybe you'll have the water come down to a certain level and not be able to go down further because there's enough sun that it pulls the water back up. So you could have soil horizons that are very shallow. If you're in a place where there's plenty of moisture and less sun, you could have the opposite. You could have soil that gets too much water locked up in it and it can't develop that way because it might turn into a bog or a swamp, that kind of thing. Stratification, that's what we call those layers. Stratification is a term where you call layers in anything in society. We have stratification of jobs and soils. Yeah, stratification. Image from the book, kind of showing the same stuff. So soil horizons, right? In a nutshell, you'll have your solid bedrock, and then you'll have different layers that have gone through some amount of weathering, depending on the climate the soil is in and the process that it has gone through. Soil textures, we'll look at an image, shows this a bit better. Really good soil is a mixture of sand, silt, and clay. any one of those things by itself. You could try to use it as soil and farm, but they all have their own problems, right? If you've ever gone to a place that has lots of clay, the water kind of can't flow through it. Again, how do we tell what the chemical composition of the soils are? You just kind of take it out and rub it around, and there's some general categories. If it's dark color, that tends to be a sign that it's rich soil that has lots of nutrients in it. I think I've talked before about red soils. Red is oxidized, right? Rust, and so in the tropics, for example, the soils will be very red. Blue, silver, gray. This is areas where it's reduced oxygen, where water's just been sitting. And then if the soil is white, which is kind of rare, but that's a number of different things that could happen. Calcium carbonate. These days it's more likely to be salts because of irrigation. So you see how much of these parent materials there are. You know, there's all kinds of different mixtures around the world. In general, if you get a really good combination of these, and there's kind of a perfect zone, but the other somewhat similar areas, as long as they're a loam of some type, they usually can be pretty good soil. Loam meaning there's some amount of mixture, not just all clay, for example. Actually, I showed you that already. All right, soil formation factors. Soil formation factors. Really, you need weather and time, right? Weather and time. And so the variable that changes depending on where you are is that weather part, right? That weather aspect. How much moisture is there? How much dryness? So this here, this is an example of a pretty healthy soil, although people will tell you grass is not actually a great thing for yards because grass itself doesn't plant super deep roots, and other kind of native to North America plants would actually have more stability in your soil, but we've gotten the habit of using grass. So, but we have lots of this good grass in Minnesota. In fact, there's lots of farms that are just sod farms where they just grow grass and then they just roll it up because the roots are so shallow. You can roll it up, right? You probably have seen that when people are like putting in a new lawn or something. So kind of far extreme, different example. This would be the soil. I think this example is from Hawaii. As you can see, not a lot of soil horizons, right? Just kind of, you got a little bit of topsoil and that's about it. And remember, the red is the oxidation. That usually means there's lots of rain in this area. This part of Hawaii does in fact get lots of rain. The other big part of the process is the organic material that is left. And so the soils are often very strongly influenced by what's growing on top of them, right? Because that's the stuff that's dropping organic material that also gets mixed up into the soil. So here are some kind of more complex soil horizons, right? And you can see areas that have forests above. They have a real good layer of soil that they've built up through time because you have all this organic material coming down. All that organic material is also a real good carbon sink because leaves and all that debris, it's made out of carbon, and so you have a good amount of that sitting, working its way into the soil while it's taking it out of the atmosphere. You can see a number of places have very kind of shallow amount of development of their soils. Image from the book looking at general trends of soils, right? Kind of similar to what we're talking about, where some places will have a lot more going on. Something that's, say, a polar climate or a desert climate just doesn't have enough of although desert is plenty warm, you need to have water to have that kind of mechanism of making the soil kind of richer through time. Some different soil horizons. Like I said, a number of these soils can grow quite well. We have some of these types of soils in Minnesota. This is going far north. This is basically if you have permafrost in some areas. This is dry weather soil. This is more of the richer kind of soil. These types of soils are kind of like over in Montana and stuff. We have plenty of these soils here in Minnesota as well as elsewhere. You can tell from the color, very, very rich soil. Less rich, right, reddish, going into a dry area. Oxisol, kind of the extreme of that red factor. The ox, again, is oxygen because it's been oxidized, which is what rust is. Rust is little oxygen particles attaching themselves to something, oxidization. Parent material. This changes obviously where you are, and this also will change the chemical components of your soil. These different parent materials, often once they're weathered, they can be very similar to each other, and they're kind of final end product of their soil development. But unless they don't develop much, which happens too. You could have a volcanic region where there's a lot of volcanic ash, but if it's in the desert, it doesn't really evolve. In a nutshell, when we're talking about parent material, we're talking about if you see an outcropping, like you're out walking somewhere and there's just some rock, that usually just an indication that type of rock is very hard and it takes a lot longer for it to wear down. And the soil right next to the parent material will usually be a bit thinner because it's a process that it takes as it kind of develops it. And the first stages of development is just you just have some runoff from some rain, and it brings some of this material down every time it rains in small amounts. As I said, you need healthy organisms in the soil, churning through it, mixing it up, basically. And of course, humans also, if that natural process isn't happening, but we want to maximize the productivity of different amounts of land, obviously we try to do with chemicals what nature takes many thousands of years to do, and put fertilizers on the soils. Most fertilizers involve nitrogen. That's why they're often explosive. If people make big bombs out of fertilizer, right? It's because the nitrates, nitroglycerin, right, big explosive. Classically, what farmers would do is they would just plant beans for a year, and that would put nitrogen in the soil, and then you switch it to your other crop. But we don't have time for that these days. We just want to plant our monocrop and have that be the only thing we plant, and we'll just add the fertilizers as we go. There's an example from the book of creating soil. A number of cities have mandated composting, and maybe you've been out to eat someplace and they have a little composting thing, and you probably don't think about it. You just kind of put your food in there. These amounts of food can be turned into really good soil. That's part of the process of how soil is made, and increasingly, especially since early agriculture in the U.S. often was not very sustainable. A lot of the soils have had lots of damage. A lot of the topsoil has just been washed away, especially when we deforested and got rid of lots of our trees and whatnot. That kind of protected a lot of soils in different places. And also the trees, as you know, create the soil by their dropped leaves and whatnot. But if we have a farm, you're not going to have a whole bunch of trees there. So you gotta find some other way to make the real good soil. Example from the book, all the kind of things that go on that basically help the circulation of air, help the circulation of water. But I'm not going to go through every single one. Some of the things that the book points out are kind of obvious, right? Like if you have a strong angle, it's difficult for topsoil to develop in that way. You might be out walking around and you'll see maybe a tree trying to grow in an area like this, but it doesn't, without stability, can't really build up. You have to have something be somewhat level. Switching into groundwater. I guess we do it time. Groundwater. I would say groundwater is what it sounds like. It's water into the ground. Typically, the water is pulled down by gravity, and it will kind of hit a bottom area. Sometimes this is the thick bedrock, right, that is often underneath areas. Sometimes that bedrock can be really far down, so you can have a real deep amount of groundwater. Just another example of how soils kind of need the stability in order to develop. So this is soil salinization. Soil salinization. This is part of the reason why a number of different ancient empires fell, but this is also an increasing problem because, well, I don't know if I've told you guys the story about household plants and why people's household plants usually die. Does that ring a bell? Maybe, maybe not. In a nutshell, who has a household plant? Who has a household plant? Any some people have household plants? So each time you water it, right, there's small amounts of salt in your water, your tap water that you drink. Like that gives it its flavor that usually you like, right? It's like, oh, this water tastes good. It has these minerals in it. Well, every time you water your plant, those minerals stay in it, right? And because it dries off. The only way you could actually wash the salt out of it is if you take your plant outside and really drench it and wash the salts out. In agriculture, also we tend to use enough water to water the plants, but you don't want to drench it because very often lots of places don't have that much water. So what happens is each year, an amount of evaporation pulls those salts up to the very top, right? You'll irrigate, and the water will come down into the soil, and then when the sun, right, it pulls the water up as it evaporates, and when it evaporates, it leaves those salts behind. So lots of areas that kind of humanity was patting itself on the back a lot when we turned a number of different kind of desert areas into agricultural, which is possible in a number of places, but you have to have enough water to wash away the salts. Otherwise, what will happen through time is you'll take an area that was kind of okay for agriculture, but not the best, and you'll turn it into, you cannot grow anything there. It's like they salted the earth, right? And like I said, this is the thing that's kind of emerging in lots of places, not just desert environments, but I would say steppe environments, places that are right next to deserts but aren't quite as dry. Those places often, it could be intriguing because it could be enough vegetation and enough water that it seems like you could have modern day agriculture there, but modern day agriculture might just be too demanding of the soils. Soil erosion. Like I said, soils take a really long time to develop and to come about, and it's pretty easy to just wash them away, because that's what rain and weather is trying to do all the time anyway. It's trying to wash everything away, right? The book has this example in Georgia of soil erosion. I would say in general, you could tell soil erosion because, well, you can see that there's some horizons here. So this was developed soil that you could suddenly see, and then of course the stark angles here. This is actually what happened to quite a bit of early farming in the early days of America. A lot of the areas, people just did not kind of know long term, right? And you had a lot of people farming in climates that were very different from the areas that they immigrated from. And so they weren't kind of ready for things like that. Modern day farming has attempted to do a number of things to try to slow down the soil loss, having contours in your farming so that the water isn't just all washed away. Yeah, these things are logical. The book has a bunch of different examples. I'm not going to go through every one, but the rice terraces is another example of trying to make land stable and trying to maximize its productivity, even if it's an environment that you would think would be difficult to farm. All right, naming soils, different types of soils. I don't want to go through every single type of soil that exists. There's a lot of them. Like I said though, there's in general these general trends. Reddish, more oxidation, black, more nutrients. You could look at all of them, like I said, if you want, in the book. General map of soils. As you can see, there's general patterns, but there's also a lot of variation, right? There's lots of microclimates here and there, which affect the soils and how much they develop. In general, you know, the tropics have that oxygen-rich soil that we've talked about before. Oh, I mentioned these first 2 points, but I didn't mention the last one. We use the soils to purify water for us. You know, you don't think about it. You know, when we take water out of, well, it's technically called mining water when you're getting water out of the ground. Anytime you get something out of the ground and you're not putting it back yourself, you're mining it. Well, when the water gets there, it of course goes through soil. It goes through a lot of rock. It goes through a lot of material that cleans it out. I talked about the carbon sink before. In a nutshell, the more organic material that a climate is able to support, the more carbon it's taking out of the atmosphere. Chapter talks about reservoirs, right? Reservoirs are very useful. Usually they're created, you put a dam on a river, right? You have a big reservoir that will open behind it. It's great because, like I said, you have a bunch of water for whatever purpose you need water for, and humans use a lot of it. The only downside to taking water from a source like this, it hasn't gone through the soil, it hasn't been cleaned. So if any company is dumping upstream, that will work its way into this as your water source. So you'll usually have to do some type of chemical treatment of the water, which raises the price of how costly it is. But it's better than not having water at all. You know, again, I think an image is a bit better. Percentage of earth water, how much is fresh, how much is groundwater, how much is in glaciers, lakes and wetlands, which, you know, in Minnesota seem to cover a lot of land. But as you can see, a real good amount of our total water is in groundwater. So there's a lot going on in this image, but I think it will help you make sense of groundwater and kind of what's going on underground. Obviously, you have rain, right? And your water will run off of high elevations, and it will also absorb into the soil, but then even in the soil, it still will have a gravity where it will kind of be going downhill eventually until it goes to an adjusted water table. Like I said, very often it'll have an ultimate kind of base level, maybe some bedrock, depending on where the area is, how deep that is and how deep that isn't. But usually the level of a river, that's a good sign of, in general, where the water table is, because that's just part of the water table that's above the ground. But the river flows can change through time as well. Rivers have their ups and downs, and sometimes they dry out, and obviously when they dry out, that's a sign that water table has lowered quite a bit. So this water will pass through the soil depending on how porous it is, right? Porous, how much it goes through those pore spaces. Fractured are kind of some of the first areas that will kind of be broken down, and how weathering makes soils. Water will get into little nooks and crannies of of bedrock and help it start to break down. Another good image kind of showing you. Well, again, you see the water table here. So when this is a good example of when it rains, you can have the water kind of soaked in, and often, well, you'll have as you see here, impermeable bed of clay. It doesn't have to be clay, but some impermeable barrier will happen in your water table. The water will slowly kind of come down through the soil and it will get stuck. When it's here, then it starts to flow down this way, because it has to. And that's when, like I said, if you're out for a hike and you see little streams kind of coming out of a hillside, we don't see a ton of these here, but if you hike over Wisconsin, we've got areas that are like that, or probably like most places in the rest of the world that are more hilly than not super hilly Minnesota. Desalinization. Desalinization is kind of the wave of the future in a number of different ways. Within the past like 5 to 10 years, there's lots of new technologies that come into play that have made desalinization cheaper. One of the biggest places that has desalinization is Saudi Arabia. But it's basically, it's what it sounds like. There's a number of different ways to do this. You could do it with electricity, where you break the water down to oxygen and hydrogen and then recombine it, and then it's water that doesn't have anything else in it, right, including salt. Sometimes they heat it up, and that's how they do desalinization. It kind of depends on how old the desalinization plant is. Newer methods obviously are less spread out than these older methods. But places are increasingly turning to desalinization because, well, as we've seen on many world maps, there's lots of places around the world that are very dry, but they're right next to the ocean, right? And it's like, well, isn't there something that could be done right next to the ocean, and it's a desert? And as we know, it's because the air is coming down from upper levels of the atmosphere, right? The Thornthwaite system of determining, well, how much vegetation an area can have. It's based on, as you see, potential evapotranspiration. I don't know if you remember way back early in the semester when we talked about evapotranspiration. Probably not. Evapotranspiration, what is that? That is how all the water gets into the air, basically, right? And how does it do it? Well, through evaporation and transpiration. Transpiration is just plants taking up water and then them kind of their version of sweat, right? Plants sweat. And of course, humans also add to this when we do sweat, but not enough that it's a substantive amount of the world's water. So evapotranspiration. So what does that mean? Well, places tend to have, if there's lots of water, right, in different places, they'll have more of this because they can, in a nutshell. Tracking a couple different droughts that had happened in the U.S. through time, you can see a lot of these tend to be, well, they tend to be in a bit drier area, right? Because this area is always a bit dry. This area, I would say this area here is not usually very dry, and so it was a bit of a surprise for that area to go through a drought for a while. But weather has been a bit erratic past several years. So the water table itself, we can change the shape of it when we mine water. Like I said, it's technically called mining, but if you have a well, if you've ever wondered the scenario of a dried up well, which there's a lot of them because, well, you had a lot of people who would put in their first wells and you'd have a water table that was at that level. But as you can see, called cones of depression. Cones of depression, that is just, if you're taking the water out, then you've taken it out of that area, and you could lower your water table. And if neighbors don't check with each other and whatnot, they can get into a bit of a competition where they're both just trying to get at those water resources that they need to share. This is also the largest aquifer that we have in the US, the Ogalla Aquifer. This is the big aquifer that basically started going dry during the Dust Bowl and the Great Depression. During the Dust Bowl, well, as you probably know if you've maybe driven through this area tends to be a bit drier. Not super dry, this isn't like a desert, some of these areas are, but you know, if you've been to Colorado, Kansas, there's enough moisture for agriculture, but it's just a bit on the dry side as far as modern day agriculture and how much water it uses. So during this is also an area that actually tends to get droughts pretty regularly. And so during the Dust Bowl, there was a bit of a drought, and a number of different farmers, well, their wells started to go dry, land started to dry out quite a bit. Even using the aquifer was not getting recharged, and so the water table that was going down was not going back up with new rains. It was just going further and further down. Porosity, we've talked a bit about permeability, either which water can flow through soil, sediments, rocks. Similar conceptually. As you can see, a little bit different, mostly because of the parent material size. Infiltration, percolation. Well, those things are also what it sounds like. Water going through the earth, and some of the images I showed you were good examples of that. Water can also be pulled back up, like I said, if you have a lot of evaporation happening on the surface, that will pull the water up. Aquifers, I think we talked about aquifers a good amount before. Aquiclude, I think I've got some picture examples of aquicludes. Roadmap of aquifers, nothing big to point out there. Oh, here's an example of an aquiclude. You know, you could have water going below an area that is impermeable just fine, but it's a bit stuck, right? And often this could be under a lot of pressure. If you have like a mountain here and rain is going, and then it goes before this layer is there, if it comes down here, it's under that pressure of gravity. And so like if you try to make, if you try to drill to try to get to this water level, if you drill through this hard parent material, you could actually have, since this is under pressure, you'll have like a big geyser, right? And that is in fact why lots of geysers happen, is because that will happen through natural processes. You'll have an area that became eroded through time, and so the water is kind of breaks free and is released. Again, I think images are the best way to kind of show these different things. So, well, you could have areas of the soil that obviously get wet when it rains, but they're not always waterlogged. And of course, you have the lower area. The further down you go, the more you have water. As I mentioned, gravity is a factor, right? So gravity, when it rains and whatnot, it'll be pulling the water down. It'll be kind of adding pressure. Groundwater recharge and groundwater discharge, those are just kind of what they sound like, right? Entry of water into an aquifer when it rains typically. And then when you need to move it out of the aquifer, usually you're going to use it under the ground surface, meaning usually irrigation. This is just another example of how the groundwater kind of feeds our rivers. Height of the water table, like I said, humans are kind of having the biggest effect on changing of these around the world. There are natural ways that these can change, but this is Part of the reason why we have oases in the desert, right? Again, the area very dry, again, because the air is coming down from the upper atmosphere, it doesn't have any moisture in it. Well, if you have any elevation that's low enough that it just peaks below the water table, this is what I mentioned before, if you're stranded in a desert, you can dig and try to find some water. It's not impossible, but don't do it at the top of a landform. Go to the lowest point possible and dig. Process of, if a body of water dries up, which happens quite a bit, especially in places that have strong rainy and dry seasons, obviously. Perched water table. These are, again, areas that often people will try to find when they're drilling, looking for water resources, trying to make a well. Another example of mountain streams. Well, let's see. I want to make sure I give you guys enough time. Actually, let me skim forward and see how much I have to still to cover. Yeah, I got too much to cover. I'll just have to keep on covering this next time. Because I want extra time. Because I want to divide you guys up into different groups so that you can interact with other humans outside your normal grouping. So I'm going to do this card thing. We all draw a card and different groups by suit. We'll see how this goes. Alright. Let's see, it looks like got a couple of big groups. Who has diamonds? Who has diamonds? Diamonds, any one cluster of diamonds? How about diamonds here-ish? Diamonds here-ish. Also, spades is a big club. Who has spades? Spades? How about spades up here? Spades up here. Who has hearts? Hearts. Hearts. How about hearts in that back corner? Hearts. And then clubs. Who has clubs? How about clubs in that back corner? That should work. All right, get in your groups. Introduce yourselves. You may not have worked together before. Let's see, I want you to do... Alright, should be doable. Just 3 questions, 1, 2, and 3 under the critical thinking questions on page 366.
So